Hi, as I stated before, I'll take a look at a couple of these problems with you. Now, number one is going to be a non-calculator, and the second one I'll do is going to be one of the calculator questions. So let's take a look at number one right here. It says, let R be the region bounded by the x-axis and the graph of this square root curve, and the line x equals 4. So first thing I'm going to do before I do anything else is I'm going to graph this. The square root of x, the x-axis, and the line x equals 4. So we know we're kind of looking for this region right here for part A. So for part A, they just want us to find the area. I'm going to drop a vertical rectangle. There's my rectangle. The rectangle is the most important part for this because it tells us everything. So if I draw my rectangle over here off to the side, I know it's going to be dx thick. Well, how do I get the height of my rectangle? Well, we know that that's just going to be top minus bottom. Well, the top is the function, it's the square root of x. Now, it's going to be in terms of x, two reasons. One, it's vertical. That was our rule the other day. If it's vertical, it's x. Horizontal, y. But the other reason is, if I drop my rectangle, which axis do I cross? The x-axis. So, my top, just the square root of x, minus 0. So, the area of this one rectangle is just x to the 1/2 of the square root of x, dx, and we're going to integrate that from 0 to 4. So if I solve this one by hand here, this becomes just what's that? 0 to 4, x to the 3/2 times 2/3. And if I solve this, I just plug in the 4, I get 2/3 times, let's see what this is going to be. The square root of 4 is 2 cubed is 8. So I get 16/3. And there's our answer. Very easy to do. Now, part B is a little bit tougher because what part B asks us to do is find the value h. So I'm going to do this in a different color. So for part B here, actually do the same color. For part B, it's going to be the same graph. There's x, there's 4. But what they're now asking is, somewhere between 0 and 4, I'm going to draw a vertical line h. Now what h will do is h will split this area in equal areas. In other words, this area on the left of h will equal the area on the right of h. So area 1 will equal area 2, in other words. So the question is, how do we find it? Well, one way to look at it, if they are indeed going to be equal areas, what that means is they each have to be half of the whole area. Well, we found in part A the whole area. So the new area that we're looking for has to be half of 16/3, which is 8/3. So now when I set up my integral, so let's just say I want to do this one. I'm just going to find the area over here from 0 to h. So I drop my same rectangle, just like before. dx thick, it's still just the square root of x in terms of its height. The area formula is still the same, x to the 1/2 dx. But what's going to be different is, I don't know where I'm going to end. I don't know where h is. See over here, originally, I knew I was going to 4, but I don't know where h is. We got to find h. So my domain is going to go from 0 to h. But I do know what the area has to equal. Because it has to be equal area, it has to be half of our 8/3. And I just integrate this. 0 to h, I get x to the 3/2 times 2/3 equals 8 over 3. Now, using our FTC, plug in the h, we get 2/3, h to the 3/2 has to equal 8/3. We don't worry about the 0 because it's just going to become 0. 3's cancel each other out, so I'm going to h to the 3/2 equal to 4. So therefore, what's h going to equal? 4 to the 2/3. And don't really quite know what that is, but we can leave it. So let's look at part C. Now, for part C, it's the same idea, but now we're doing it for volume. Alright, so let me go ahead and put a sheet of paper. Whoop, not that one. Sorry about that. Let me grab another sheet of paper here for part C. There we go. Now for part C, we're going to do the same thing, but for the volume. I want to now revolve it about the x-axis, so the same area. So I'm going to take the same area, and now I'm going to revolve it about the x-axis. Now, because I'm going about the x-axis, the question: do I want to use shell, or do I want to use our disk method? Well, if I drop it vertical, disk is going to be much easier for us, right? One, I don't have to change it in terms of y. If I want to do shells, I could, but I have to change in terms of y. So to solve this one, draw my when I revolve it, we do get our disk. So I make my disk. It's dx thick. There's my x-axis. My radius, yep, there it is. There's my radius, is just x to the 1/2. Top minus bottom. So the volume is going to be pi times my radius squared dx. So my volume, pi x dx, and I'm going to integrate that from 0 to 4. Very easy to do. Integrating it, we get pi from 0 to 4, x squared over 2. And I just plug that in, and what do we get? What's that? If I plug in the 4, that becomes 16 over 2, which is 8. So we get 8 pi. Again, we don't have to worry about the 0 because 0 squared is just 0. So there's my volume. Now, for part D, same thing as part C. Now we're going to draw a vertical line. Same idea. Here's 4. Same idea. But now we're going to drop a vertical line at x equals k. That's now going to put my volume in half. So I don't know where that is, so I'm just going to drop k anywhere I want to. There's k. In other words, when I revolve it now, this volume will equal this volume. Again, I don't know where that's going to happen. So I'm going to set it up. Oh, look. Are we okay with this? Get it? Okay. So when I set up my integral, same idea. I'm going to start over here. I'm going to rotate my disk, my line, get my disk, dx thick. The radius is still x to the 1/2, but now when I set up my volume, no need to reinvent the wheel. I crack myself up sometimes, reinvent the wheel. We already have it up here. We know the integral is going to be pi x dx. Now the problem is we don't know we know we're starting at 0, but I don't know where I'm ending. I'm ending at k because I want to find out where k is going to be. That's going to make my volumes the same. So I call that k. Now, Mr. Wernow, can we go from k to 4? Yes, you can. You'll get the same answer. But working with 0 is nicer because, like we said, the FTC works out nice for us. So now, here's what we know. We know that the volume has to be half. So let's talk about the volume. Ready? From 0 to k, the volume is half 8 pi, which is just 4 pi. So I know that this has to be 4 pi. Now it's kind of neat. Pi's cancel. I don't have to worry about those. When I take the antiderivative, 0 to k, x squared over 2 equal to 4. If I plug it in, k squared over 2 equals 4. What's k going to equal? That's right, square root of 8. And that's where we're going to rotate around. So take a look at the next example. I'll take a look at one from the other stuff, from one of the calculated questions as well. I'll see you then. Bye-bye.